Hello, I'm here today to talk to you about a sheep disease that occurs worldwide called parasitic gastroenteritis, and in particular I want to focus on the sheep worm Telodrosergus circumcinctor and how it is resistant to the anthelmintic drug that's used to treat it, called Ivermectin. So if you look at the top left of the slide, you can see that 100% of sheep are infected with worms. So this is not a disease that we can eradicate, but we can control it. We use anthelmintic drugs to control that disease, but resistance to anthelmintics, just like antibiotic resistance, is on the rise. How would we tell if an anthelmintic is effective? We would go onto a farm and we'd collect some sheep poo. We'd do a worm egg count and we'd treat the sheep with our drug of choice, so with Ivermectin. We go back 14 days later, collect some more sheep poo, and we do a second worm egg count. Resistance is diagnosed if there is less than 95% reduction in that worm egg count. And you can see some of the eggs here on the top right. Unfortunately, anthelmintic resistance is on the rise. More and more farms are having Ivermectin resistance diagnosed, and recent studies suggest that over 50% of farmers have got Ivermectin resistance. What we need are effective tests to be able to tell a farmer whether or not a management practice that they're employing is accelerating or delaying this anthelmintic resistance. But the fecal egg count reduction test that I've just told you about has got a number of limitations. So if you see this graph here, you can see there are lots of different colours represented. Each one of these colours is a different worm species, but not all worms are equally important and not all worms are equally resistant. And we can't tell just by looking at these eggs what worms are present. So for my PhD, we want to find a molecular test looking at the worm's DNA that will allow us to tell a farmer, is this worm resistant to Ivermectin? So we've used next generation sequencing technologies, including dd-RAD-seq and pool-seq. We've taken UK field populations of worms, using both individual larvae and pools of larvae, and we've sequenced these worms' DNA. And we've then aligned the DNA of these worms to a worm genome, much like we might align our own personal DNA to the human genome. And we're then looking for differences between the pre-treatment and the post-treatment worms, between the susceptible and the resistant worms. And when we find these differences in the genome, we see a peak like this. And we're then looking within these peaks to find genes or mutations that we could use as molecular tests to be able to tell a farmer, does this management technique impact on resistance? Is this management technique sustainable for future sheep production? Thank you.